All right, I think we can get started. So thanks everyone for joining us today for our discussion, the warehouse native difference in experimentation and product analytics with Sharma from Eppo and Alex Lee from Kubit. My name is Alexa Guerra. I'm on the marketing team here at Eppo, and I have two housekeeping notes before I pass it over to our speakers. One, I'm recording this session and I will share it with you all after we are finished here. And then two, we will leave time at the end for questions, but if you have questions during, just feel free to drop them in the, click the Q&A button at the bottom here, drop the questions in and I will read them out for Alex and Che. And so with that, I'm going to pass it over to you, Che, for the first intro. Tell us about yourself.
Sure thing. Hey, y'all. I'm Che. I'm the CEO here at Eppo. We're this warehouse native next-gen A/B experimentation platform, heavily inspired by what we built at Airbnb and then adapted to a bunch of growth companies. So I'm excited to chat here because I feel like warehouse native, it's not only the future of analytics infrastructure, but it also just has special importance for experimentation. I think for a lot of data folks, once you realize applications can be built this way, you start to hold all your applications to a higher standard. So we're going to be talking about that. So thank you, Alexa.
No problem. And then Alex, tell us about yourself.
Shay. Yeah, thank you, Alexa. Excited to be here. Hi, my name is Alex Lee. I'm the CEO and founder of Kubit. We are the first product analytics platform, which is warehouse native and built specifically for the product and data teams together. So we give our customers the ability to get instant insights about their user behaviors, like engagement, retention, and cohort analysis. But we do it in a warehouse native way, which means we talk directly to our customers' data warehouse, which is already part of their modern data stack. In this way, they got one single source of truth, as well as break down the data silos. Yeah, thank you. Glad to be here.
Awesome. Okay, so let's get started. I think the best way to start is by framing the problem. So can you tell us what the world is like if you're, say, a data leader and you're not working with warehouse native tools?
Who you want to direct to first?
Che, I'm going to direct it to you first.
Okay,
Set the stage.
Okay, so yeah, I've used a whole bunch of third-party analytics tools in the past. You know, the Amplitudes of the world, the mixed panels, a bunch of chart moguls, and I think when you're in the data world, the problem you usually have with these is one, you have a huge security risk from having your data just live across the internet, all your customer data, but just from trying to make data analysis into something trustworthy. Where you're going to like make serious high scrutiny decisions off of it. The problem you have is like, you have no idea how it was prepared. There's a bunch of, as every data person knows, every chart has a bunch of micro decisions that went into it about like what data is included, how it's aggregated, you know, what to clean, how to handle it all. And when you kind of egress all the data to third parties, you're kind of outsourcing all of that, which, you know, is a sane choice if you don't have data people, but quickly becomes like maddening when you do have data people. Where suddenly every stakeholder has to get two different answers, one from internal, one from external, and those answers are different. And it just starts eroding trust left and right. So, you know, in the experimentation world, this is especially true because, you know, it's such a precision game, but it's kind of true across the board.
Yeah, echo on that. Similar experience here. So I started Kubit 5 years ago because before that, I was the CTO at a company called Smil. We build music apps with about 50 million monthly active users. So we started using product analytics to figure out user behavior. However, at the moment, that's about 8 years ago, the only choices were mixed panel, Amplitude, and Optimizely for the A/B testing. All of these tools forced us to use a third-party SDK or do ETL to send our data to their data silos. And we experienced a lot of painful issues there. So one is, like Che mentioned, building ETL is just such a painful job. You have to babysit it, and very often it just breaks, and you have to work with a third party, do this acrobat dance, try to figure out what's going on, or even worse, you have to backfill the data. Then that will be a weeks or months terrible experience going through that. But even bad is a lot of these tools, because they are a limitation on their data silos, they actually force customers to sample their data, or they only take a portion of the data. And also they provide the insights through a black box. So nobody knows what's going on because you can never see the data stored in Amplitude or Optimizely side. And also you have to blindly trust whatever the insight they gave you through this sampling. So now like Shay mentioned, what if you realize one day you lose some data, or you want to backfill some dimension table to the like 6 months ago? Well, guess what? They will charge you a huge amount of money, but still in the end of the day, how can you trust whatever they did is correct, right? Because you have no way to troubleshoot or look under the hood to see what's going on here. So beyond that, also, yeah, the data is stored in a third party. You have no control whatsoever. So data governance, data quality, and also there could be a security risk like a data breach, etc., which is totally out of your control.
Yeah. Yeah, and just to give a really concrete example of these sorts of things. So my most recent gig was at Webflow, which is a website builder, no-code website builder. And there were just two kind of examples that are most acute here. So first, I was there when COVID broke out. And like every other company, when COVID broke out, we immediately went to our business metrics to see like, how much exposure do we have here? Like what's about to happen? Are we, going to fall apart, or how are we going to hold up? And we, at that point, this was in the very earliest days of the data team, but while we were still getting core reporting together, we used a tool called ChartMogul, which kind of did a lot of the MRR reporting by subscriptions and all that. ChartMogul said, nothing to fear. It all looks good. It's all great. What we found out when we did the data work ourselves was there was a skew, a kind of light plan skew that was churning really rapidly. It's basically like that skew is going to be, I don't know, half its value or less, like in a few weeks. And the reason we didn't notice it is that ChartMogul uses different dates on when something churns. And so it was going to be something that we wouldn't see until, the end of the month versus the beginning of the month sort of deal. So it's an example of a micro decision that you're outsourcing and that you're just not aware of. Is like, when does a plan churn? Does it churn at the moment that the paid period runs out, or the moment that a user like just clicks cancel? And so that micro decision, not only are you making the decision differently, but you don't even know how they did it because it's all black box. Another example would be at Webflow, we were big Amplitude customers, and I love Amplitude a lot. I think it's a great piece of software, but the problem we had was our most important data was subscriptions from Stripe, and that unfortunately is only available in the warehouse. Stripe does not let you kind of egress that sort of data to product analytics tools, and so instead we leaned on this, hand instrumented subscription upgrade event, which was wrong something between 10-20% of the time. And so that just set us up for this constant friction where someone goes into Amplitude and they see subscription upgrades going in one direction, and the data team looking at the Stripe data sees something else, and it just constantly leads to chaos. So it's what happens when you're dealing with different data sources. You have to deal with egressing and all the micro decisions that are forking.
Yeah, exactly. That's why we call it evil silos, right? Regardless intentionally, it's just the evil approach. For the customers we're serving with.
Yeah, and it's especially prone on lifecycle metrics. If you're an e-com company, for instance, like if you are not warehouse oriented, just use event analytics, you're probably looking at a lot of like purchases or something. But as most e-com folks know, you also have to look at returns or margin, or some, these sorts of concepts, which are highly modeled always in warehouses. So, the warehouse native thing really matters for anything lifecycle oriented.
Yeah, to be able to bring the product data with transactional data and everything together. That's the whole thing. We want to drive through this modern data stack and warehouse native approach.
Yep.
Okay, so then Shay, I'm going to ask you to define what warehouse native actually means, and maybe tell us a little bit about how this approach changes the world in the experimentation case.
Totally. So all of history, the way app analytics software has worked is that you ship your data out to the application. There's some sort of application which before might have been some sort of desktop app, but these days it's all cloud infrastructure. And so you're shipping your data to some servers that belong to some third party. And then they are going to operate on that, aggregate it, serve some charts. The warehouse native thing flips that on its head, where it says, instead of bringing the data to the application, why don't you bring the application to the data? The data sits in your warehouse. That's one of the big changes in the past 5-10 years, is there's been a massive consolidation onto Snowflake, Databricks, Redshift, BigQuery. Basically most companies use some form of that. There's a few data lake models outside of that, but by and large, there's kind of a few set of things that exist in customers. And because it's both consolidated and publicly addressable, you can now have third-party applications that just kind of connect to these databases and operate within it. And so this has a bunch of big advantages because there's no data duplication. You're not creating shadow warehouses. You're not having to egress, again, all the security things, which we should talk about in kind of a bigger sense, because that kind of goes beyond, just our job as data people into just being good stewards of customer privacy. But for a data person, what it concretely means is that, you have complete observability, auditability of your database. All the charts that I'm seeing, I can now trace every single transformation aggregation decision that was made to get there. For example, that subscription churn thing I said, which is, at what date does something churn? You can just look at the queries and see, here's the date that was used. And so I know what happened. I can, if someone in leadership is questioning, I can actually say what was different. If you're choosing to throw out some data or to aggregate in a certain way, then, you can see all of that. So this is, important for just building trustworthiness, both because you're using one version of data and also because you can trace all the decisions. Now, this is especially important for experimentation because I think one of the things that's very important about experimentation is that it's a high precision, high scrutiny process. It's high precision in that, percentage point differences of 1%, 2%, 3% matter. A lot of experiments, their positive effect might be somewhere on the 2 to 3% if you're a large company, 5, 10% if you're smaller. And the whether or not you actually had a positive or negative direction is going to mean, do you decommission a bunch of code you spent time writing, months of engineering time, product design time, based on this experiment, you might decommission it all or launch and celebrate it all. Either it's going to end up in the, trash bin of history, or it's going to be canonized in institutional knowledge. So this is really kind of high scrutiny, high precision stuff. So, and there's also for experimentation, a bunch of really esoteric micro decisions, like, do you Windsorize your results to, clip the 99.9th percentile and deal with outliers? Like, how do you handle outliers? What sort of things are you plugging into your stats models? Like, there's a bunch of things beyond just summing that's going on. So to be able to peer into it, to scrutinize it, it's just super important.
Got it. Okay. So on the experimentation side, being able to trust the data is critical because it truly is a precision game.
Totally. I mean, just consider, so I'll bring it back to the Webflow example, and again, gets back into these lifecycle metrics. When we first started out, the first team to run experiments was the onboarding team, growth team. And they ran a bunch of experiments to do some sort of guided onboarding because Webflow is a very complicated product. It's very hard to learn. So they made this big guided onboarding flow and they launched this experiment and started analyzing it in Amplitude, again, a very kind of egress product analytics approach. And it showed all these glowing results. It showed all these like, wow, we increased subscriptions by something like 5-10% or something. Like, that is awesome. We should celebrate that. When we looked at it in the warehouse sense, we found that all of those 5-10% churned immediately. Like, they were essentially just mistakes, and so if you use the very warehouse lifecycle approach to this, you would not consider that to be a very successful experiment. It just made a bunch of erroneous upgrades that turned into nothing. And so, again, the lifecycle metrics thing matters, using the correct data, because, even if those subscription upgrades, 10-20% of them were just faulty data, was also bad. As a result, once we actually saw this and we saw that it wasn't working, we decommissioned all that code. We rolled it all back. We didn't want to maintain stuff that is a bad user experience. So high scrutiny, high precision.
Yeah, absolutely. Yeah, actually, I have an example. One of our biggest customers, they were using Amplitude for the analyze the A/B testing data, experimentation. But turns out that during the ETL egress process, the tagging was not done correctly. So in the end of the day, they couldn't differentiate if a user's event is before or after the treatment of the experimentation. So actually, you already can see how massive impact that kind of wrong insights could cause. But the worst part is it took the customer almost like 3 months to realize this mistake has happened during the data ingestion time on the Amplitude side. So which completely just disapproved a lot of the money and the budget and time they spent in the last 2 months of experimentation. So that's also one of the reasons, yeah, a lot of these experimentation and data insights has to live in the single source of truth of the data warehouse native solution.
Got it. And Alex, I'm curious to hear more about how you see warehouse native architecture benefiting folks on the product analytics side.
Yeah, absolutely. So as she mentioned, one of the example, like you combining Stripe's subscription data with product insights. So to make a product analytics solution works for the whole team, for the whole life cycle of the users, you have to stitch a lot of data together, from transactional to user behavior data, right? Transactional meaning the subscription, purchase, or these e-commerce data. And also sometimes it's also generated by machine learning algorithm like a user persona. So you can tag them and analyze them after the fact. While the product data usually means the user behavior events, which screen, which button the user clicked in the app. So as we see previously in my personal experience as well, a lot of these product analytics solution in the past, like Amplitude, Mixpanel, they require their customers to do a lot of this work. So not only embed SDK to send a product data to them, a third-party data silo, but also you have to build this ETL or some kind of stitching process in your own data engineering infrastructure and send them to a third-party silo. So this kind of thing is very error-prone, like Shay already pointed out. And also, it's because it's a black box. You have no idea how these data was stitched together on the third party's hand. But also, this whole product analytics is an ecosystem, right? It's not only about one vendor. For example, you may use different vendors for acquisition, some for A/B testing, some for the like a user customer re-engagement, like a Braze, right? A lot of these data has to come together to show you the life cycle of the user through a self-service matter. So in the past, when people does that, they have to build a lot of API integration or ETL. For example, you have to pull data from Optimizely to Amplitude, from Braze to Amplitude, from all the other parties like Just Branch. So in the end of the day, you are duplicating data all over the place. So with the warehouse native approach, the most advantage is you give the control back to the customer, because in the end of the day, data is a very precious commodity and they have to own it themselves. And instead of building all these crisscross between partners to egress data everywhere, they just need to bring all the data together into their own data warehouse and then use other solutions to bring the single source of truth. So through that process, you break down data silos, as well as you increase your data quality. And in addition, you have the data governance and data control. And plus, the modern cloud data warehouse make it super easy nowadays. So as you guys can see, there are technologies like a data sharing, right? And Snowflake called secure data sharing, Databricks called Delta sharing, BigQuery has a data set sharing since day one. So because they separate the storage from compute, so they enable the data set to be shared across different vendors or partners without a need to make a single copy of it. You don't need to copy a single byte, and instead you can directly mount to a third party's table and then do the compute. So through this kind of process, the data warehouse native becomes a definitive trend for everyone to utilize this sharing, to utilize this ability to consolidate data in one place. And also, what can replace a same data warehouse if your goal is getting a single source of truth? So all of these coming together makes it just a very natural choice for any product analytics or experimentation solution. They have to be on the warehouse native right now.
Got it. Okay. So the warehouse native approach is helping you move toward a single source of truth, building more trust in your data, de-risking some of the privacy concerns you might have. I'm curious if you can tell us more about, I know there are a couple of axes along which you save time or save money. So if you could dig into that a little bit more. Che, I'm going to pass it over to you first.
Yeah, when you think of just a large company, and this really gets into when you're kind of enterprise, suppose you're Twitch or something and you have like, you're a live streamer of tons and tons of data. It turns out shipping all that stuff is very expensive. Shipping it across the wire to some third party. So like there's a whole bunch of cost that's being incurred just by the replication process. So like that's a whole bunch of money that's been saved because you're not replicating. And then in terms of the compute, there's various kind of optimizations you can do by having kind of stuff within this, these kind of highly performant elastic cloud databases. The optimizers of Snowflake, BigQuery, et cetera, have gotten very, very good. And for the vendors that have figured out how to use those optimizations, you get a ton of cost savings. And then the last thing, of course, it's worth calling out is like there's a huge human cost to dealing with this constant, degradation of trust. All those vignettes I told you about finding the difference in churn methodology or the difference in lifecycle metrics, that was like a week or two of analyst time. Right? There's a lot of time spent trying to reconcile that stuff. So there's a huge kind of labor cost of just dealing with constant, differences in results, constant like reconciliation processes. So kind of those three are the kind of big costs that come to mind.
Got it. Okay. And Alex, what about on the time to insight side?
Yeah, absolutely. So once you have the data consolidated in one warehouse, I mean, a lot of these things just become a natural process, and you can get insight much faster instead of dealing with multiple parties to figure out what's going on. So like Shay mentioned, all these cost of the maintaining bad jobs or troubleshooting on analysts, but also I want to add on the impact of bad data, right? The moment you find the bad data, the opportunity cost is already there. You wasted so much time and you could have been doing something much greater. And even worse is the data quality is distributed across multiple data silos or data partners in the past, but with warehouse native approach, so you don't need to deal with these kind of things. Also to add on that, previously what I mentioned, the data sharing protocols, all of these are real time. So in the past, a lot of these ETL jobs or copying data, they always have delay and latency, right? So you may be 4 hours behind or a day behind. God forbid you have another bug in the code. Now you have to reprocess last 6 months of data. But with this warehouse native approach, everything is real time at your fingertip. And if you make a change in the past, you say, hey, I figured out 2 months ago we had a bug and some data was not correct. Let's delete it or let's update it. Well, it will reflect immediately in the warehouse native solutions like Eppo and Kubit. So all of these makes the time to insight a great benefit of the warehouse native approach, while we are de-risking all the impact and the loss aversion, and we're making it much streamlined for any CFO or data engineers to buy into this modern architecture.
Cool. Well, that sums it up pretty nicely, I think. So at this time, I'm going to move it over to Q&A. So if any attendees have questions, drop them in the Q&A section on Zoom. So I do have one, which is, how do you manage warehouse native architecture when you're dealing with multiple data warehouses?
Alex, go and take this one, and then I can chime in.
Yeah, definitely. So for me, usually I would say is it depends on your use case. I mean, in the end of the day, I think one use case probably deserves one warehouse. I mean, because you have to utilize the warehouse optimization to run certain query, whichever. So in this case, what I mean use case scenario, like Shetan mentioned, subscription retention analysis, right? Or you are using a machine learning algorithm. So for me, the decision point is which warehouse is the lead in your use case, and how do you consolidate some data into a specific one for that use case. So, but in the end of the day, your solution provider or your vendor should not be picky about which warehouse they will provide the solution. So when we say warehouse native, it should be possible for the vendor to talk to any of the warehouse you guys have. I know a lot of customers of us, they're choosing between Databricks versus BigQuery versus Snowflake for different use cases, right? Obviously, one of them maybe is cheaper on storage, the other is cheaper on compute, but for different workload, like a batch process, you may want to choose one, but real-time analytics, you may want to choose the other one. So a warehouse native solution should not limit your choice. Instead, it's opened up all these possibilities. So now you can be at freedom to say, hey, I want to transform some of the data into this warehouse for this purpose, like a real-time analytics. But for the other machine learning, I'm going to move it to the other. For experimentation, I may choose another one. So for me, this is just a natural thing, and nobody should dictate what the customer should do. But in the end of the day, all these solutions will help the customer to make the best choice for the use case they're facing.
Got it. Okay. Another question is, would a data quality tool fix some of these problems happening upstream that the warehouse native approach is addressing?
Yeah, I can take some of this. So data quality tools, I mean, one, there's a big gamut of it, right? So you have your kind of observability approaches where you pointed at warehouse tables, which, again, that's only going to help if you're reading from the warehouse. And two, there's like kind of contract type of services, which is like, attaching schemas to events as they fire and stuff like that. So the problem, like a data observability tool is always helpful for improving your data quality. We're friends with a lot of them. Improving your event quality of saying like, the subscription upgrade event at Webflow is 10, 20% off from the other one. It can help with that to some extent. Usually they're pretty good at detecting schema changes, but not necessarily like omissions of events or, that sort of thing. But the other thing is that some of this stuff is not actually a data quality problem. It's just the fact that the metric is a lifecycle metric. Say the idea that there is like a subscription that you upgrade and then you churn, or an e-commerce thing that you purchase and then return. Like the problem is that these, just have a little bit more fluid definitions, where like there might be an entity resolution problem where like the return might be off of some address or something, and the purchase is off of a cookie or something. I'm making up examples, but like cookie to user ID sort of mapping is like a very intentional kind of decision that a company just has to make around some of that logic. And so like lifecycle metrics where like a single moment in time event doesn't actually describe the metric you're talking about is usually something that just has to get pushed to the warehouse. Another example would be multiple points of sale. Suppose you're a big box retailer of some sort and you got e-commerce sales and you got in-store purchase sales. Like those sorts of things, again, the data is going to has to get centralized somewhere to come up with total sales. That somewhere is like logically a warehouse. And then once you're doing things in a warehouse, then the warehouse native stuff comes in again.
Yeah, and actually, to add on that, from my experience, I think the data quality is not just a tool or a solution. I mean, it's a very social engineering topic. And frankly, when we see a lot of customers, the first thing we will recommend them to do is have a data dictionary, catalog your events and what each event does clearly, either through a spreadsheet or using a tool. I mean, we actually have a solution for that as well, because nothing can replace this kind of knowledge, or to put it the other way, all the events carries a very important context. You have to make sure everyone understands when they're analyzing it or when they instrument it, they know exactly what this event means. Actually, I have my personal, very painful lessons before. So in my last company, we had a funnel. We tried to analyze the logging event divided by the number of homepage people saw. So supposedly it's under 100%, right? Because only a certain percent of people were logging when they see the homepage. Well, it turns out in production, we saw a Facebook login conversion rate is 300%. We're like, hey, what's going on here? Why does this happen? Well, in the end of the day, what happened is a login through Facebook versus sharing on Facebook share the same method in the code. And the engineer has no clue what you're asking them to do. They just put the same event there. So now you're combining the real login from the homepage plus the login when people do the Facebook sharing together, and to divide it by the homepage count, obviously it's over 100%. So a lot of these kind of things happen subtly or unintentionally in the system. So to really manage the data quality, it all starts with capturing the data dictionary, capture the events definition, but obviously all these tools that Shane mentioned about all these observation or real-time monitoring should be definitely very helpful as well.
Got it. Okay. And one more question. Can you talk more about how warehouse native architecture will impact compute costs? You all hinted at it, sort of touched on it earlier, but can you give some more detail about what's going to happen there?
Yeah, I can start. So, the one of the differences warehouse native computation costs is that it's going to be on the, I guess it depends on how you architect it. Like it's going to be either on the customer side in their warehouse bill, or it'll be on the vendor side, in some of these shared data set methodologies. The way I think about it is like the compute cost is there no matter what. Like, at some point data gets crunched and it costs money. So it's like, it's either going to be in your vendor bill or it's going to be in your Snowflake bill in one way or another. So the big thing is just, as a vendor, are you being a good steward of cost? Because at the very least, to the benefit of these third-party egress tools, like if they do a bad job, they kind of eat, there's like skin in the game in a certain way, they eat the bill. When you're a warehouse native company, like you need to be, very careful that you are being a good steward and controlling the cost. So, part of the thing is being an Eppo in the space, like you have to invest a ton in optimizations. And, we've reduced our warehouse costs by something like 95% or something. We figured out every single nook and cranny of what Snowflake and BigQuery and Redshift and these companies are doing. And so, there's a bit of secret sauce in there, but like there's a lot of opportunity to really, really save customer money.
Yeah, absolutely. And to add on to that, one is once you remove a lot of the ETL jobs, I mean, your cost, because you're not copying data around, that cost already reduced quite a lot. But in the warehouse native world, like Shane mentioned, yeah, customer do have a choice, right? They want to do the compute themselves, or they want to offload this to the vendor side through the data sharing protocol. But from my perspective, I feel, yeah, it's just an undeniable trend. All these warehouse vendors, they're trying to provide ways to make things more efficient and lower the cloud cost, right? Compared to like 10 years ago, how much AWS cost versus today. So a lot of things are going, but also the optimization can be done by the vendor because like Eppo and Kubit, we are professional doing this every day, 24/7. So we can optimize our queries much, much better and faster because we know the pattern. And also we see enough customers, billions of events a day, 100 millions of monthly active users. So that's actually one thing I would like to call out is a lot of these things. Plus, we also have some caching layers optimization we done in as our secret sauce, right? So a lot of this, I think this should be definitely going towards a cost saving on both sides, but it takes a collaborative approach. I mean, that's also another reason we are transparent, right? A lot of things we do here because we use your warehouse native data or compute, you can see exactly what's happening under the hood. So there's no something we're lying about or something we're hiding. Pretty much it's a collaborative approach we can achieve together to reduce the computer cost to both benefits.
But okay, well, that wraps up our questions. So if there aren't any more questions, we can wrap our discussion. And thanks everyone for joining us. And I will send out a copy of this recording. Thank you, Alex and Jay, for speaking today. And yeah, happy Thursday.
Yeah.
Thank you, everyone.
Thanks, everyone.
Yeah, thank you.
Happy Thursday.
Bye.
Bye.
Bye. Take care.